Hi everyone, welcome to Pre-Calculus Lesson 6.5, the Law of Sines. So far in Pre-Calc, we've talked about using trig functions to find missing measurements on right triangles. But the question comes up, well, what happens if the triangle is not right? So we have two different laws that we use to figure that out. So in a triangle that is not right, you are allowed to use the law of sines. And the formula looks something like this. It says for any triangle ABC with side lengths A, B, and C, then the sine of angle A over side A equals the sine of angle B over side B, which equals the sine of angle C over side C. And the thing to remember is that the angle is always across from the side that it goes over. Okay, so sine A is always over side A, and these A's are across from each other. So if this angle is 30 degrees, then this has to be whatever side is across from it. So it would be sine 30 over maybe 10 if that was a 10. Okay, now they always show it in this group of 3 fractions, but what I like to do is I like to change it and just say sine A over A equals sine B over B. And remember, A and B are just arbitrary names. As long as you make sure that the angles across from the side, it doesn't matter which angles and sides you're using, whether they're labeled A, B, or C. And this is just a proportion, and you would solve it using a cross product. So you do B times the sine of A equals A times the sine of B. And then you'd go ahead and divide by whatever you need to solve for the measurement that you need. Okay, so let's take a look at our first example. Example 1 says, a satellite orbiting the Earth passes directly overhead at an observation stations in Phoenix and Los Angeles, which are 340 miles apart. At an instant when the satellite is between these two stations, its angle of elevation is simultaneously observed to be 60 degrees at Phoenix and 75 degrees at Los Angeles. How far is the satellite from Los Angeles? So they've also given us this picture. Notice they put in the distance from LA to Phoenix as 340, and these are the angles of elevation they gave. And they want us to solve for this side over here. Now, you always need to know an angle that's across from a side that you know. Notice we know this side, but we don't know this angle up here. So that's what we're going to start off by finding. So you may recall that all of the angles in a triangle add up to 180. Pause the video, see if you can solve for what S is, and then press play, check your answer, and then we'll talk about the next step. So I did 75 plus 60, and I subtracted it from 180, and that got me 45 degrees. So angle S is 45 degrees. Now what you're going to do is you're going to make a proportion and solve it. So remember, it's sine of the angle over the side that's across from it. And then remember, you need to use this side. So sine of another angle over the side that you don't know. So that's going to be your x right here. Okay? So see if you can make your proportion and solve it, and then again, press play and check your answer. I did the sine of 45 over 340 equals the sine of 60 over x. And I picked this because the 60 is across from the side that I wanted to know. So I'm going to do a cross product. I did x times the sine of 45 equals 340 times the sine of 60. Now to solve for x, I need to divide by the sine of 45. So I got this, and I put it into a calculator, and I got approximately 416.4 miles. So that's how far away the satellite is from Los Angeles, and that's my final answer. Let's take a look at another example. In example 2, our directions are simply solve the triangle, and they've given us this triangle over here. And what they mean by solve the triangle is they mean to find all of the missing side and angle measures. So just like we did last time, you're going to find the missing angle here, and then you're going to use the law of sines to solve for both of the missing side lengths. So pause the video, try and do that, and then press play to check all of your answers. So for the missing angle measure, I did 20 plus 25, and then I subtracted from 180 to get 135. So angle B is 135. That's my first answer. The next answer I'm going to find is side A. Now, I always like to use whatever's printed on the triangle whenever possible, because just in case I accidentally subtracted wrong, I won't have all wrong answers. I'll only have one or two wrong answers. So always try and use what's printed in the triangle. So I'm going to use the sine of 25 over 80.4 as my first fraction. And then for A, I'm going to do the sine of 20 over A. So this is my proportion. I did A times sine 25 equals 80.4 times sine 20. I have to divide by the sine of 25. Now, if you don't get the right answer, there are a few suggestions I can make. You may have forgotten parentheses around your numerator, or what you can do is type into your calculator 80.4 sine 20 and hit enter, and then divide it by the sine of 25. Okay? Don't round any numbers unless you're told to round. Now, these I did round to the hundredths place because I couldn't keep the whole decimal, but don't round like 80.4 times the sine of 20. Don't round in your calculation steps because that will throw off your answer. Okay, for the side B, I did the same exact thing, sine 25 over 80.4, and again, I'm using the numbers that were printed in my triangle. Sine 135 over B, I had no choice but to use this angle. I solved and found out that B is 134.52. Okay, just another side note, if you're getting wrong answers and you did check about your parentheses and you did check that you're typing everything in right, check your mode on your calculator. We're using degrees in these examples, so make sure you're in degree mode. Okay, let's talk about what we call the ambiguous case. You may recall in geometry class when we were talking about congruent triangles, there was one abbreviation we were not allowed to use, SSA. If you read that backwards, you will remember how we remembered not to use that one. Now, the reason that this occurs is because if we have an angle in a triangle, and then we have the two sides that connect to it, this one here and that one there, we don't know if this top angle is obtuse or acute. So if it's the acute angle, you'll end up with this blue triangle over here. And if it's the obtuse angle, you'll end up with this big outer triangle here. And we're just not sure which one it is. So what we do is we find both angles. So when you do your inverse sine function, always subtract with 180. Then check to see if it actually makes a viable triangle. Sometimes it will, and sometimes it won't. So let's take a look at some examples, and I'm going to put them in a separate video, and you'll see how this all works.